Hi friends, welcome to this lecture on resolution in artificial intelligence. Do you have questions like what is resolution, and do you want to know where do you apply this resolution technique to solve the real world problem? And also, you may be interested in analyzing the application of this resolution technique in propositional logic as well as in predicate logic. So you will find the answers to all this in particular lecture. First, let's get started with what is resolution. Resolution is a single inference rule which is used in both propositional logic as well as predicate logic. We apply this rule to derive logical conclusions from a given set of statements through logical reasoning. We usually generate the proof by contradictions, or we can say proof by reputations. So if a set of statements are given, we have to convert those statements into propositional logic statements. Then we have to take the goal statement. We should negate that goal statement, and then we try to prove that goal is true. So how do we prove that? We prove that by contradiction. We take the necessary classes together. We resolve them by applying the inference rule, resolution inference rule, and we prove that the statement is negated statement is correct. So sometimes we apply unification technique in resolution. So we'll discuss that when we solve problems on predicate logic using resolution. So when we apply this in propositional logic, we usually apply only to the classes which are in disjunctive normal form. Before moving on to the application and examples, problem solving on this topic, let me first discuss few terminologies. So you should know what is class. Class is a propositional formula. It consists of a finite set of literals. Literals are nothing but propositional statements, we can say. And these are connected by using logical connectives and or not or implication. We generate a distinction of literals or distinction of literals representing the statements. So this will be shown like this. For example, A or B. A is one sentence you can consider, and B is another sentence. We connect these two by using a OR operator. So the disjunctive normal form usually generated by applying OR operator on a set of classes. So we connect a set of classes by using OR operator to get this disjunctive normal form. And for conjunctive normal form, we use AND operator to connect. We sometimes eliminate biconditional implication. For example, if you have a statement like if P then Q, which implies if Q then P, then we can generate if P then Q for this. So we can replace if P then Q with the extended formula like this, or we can reduce these by removing the conditional implications present in the statement. For example, if you take sentences like I am breathing if and only if I am alive, then it is true that if I am breathing I am alive. Likewise, we can express this in this way as well. If I am alive, I am breathing. So like this. So these two conditionals can be reduced by eliminating the biconditional implication. We also apply implication elimination. If you are having a statement like if P then Q, then we can generate Horn classes of this if P then Q can be written as negation P or Q. And sometimes we also take the negation inside. When you are taking the negation inside, the negation of if P then Q becomes negation of P or negation of Q. And we have to apply distributive law as well sometimes, so to generate this conjunctive normal form. If you are having a form like A union B intersection C, then we can take the A inside, A union B intersection A union C. Like that you can generate the formula, logical formula. So these are some basic terminologies you should understand. Let us now discuss the steps involved in solving a problem in propositional logic. So let us see how to apply resolution rule, inference rule to solve problems in propositional logic. First, we have to generate the propositional logic statements for the given set of sentences, and then we apply inference rule to generate classes in disjunctive normal form. Then we negate the goal statement, and then we use those classes together to prove the negated goal statement. So when we apply the inference rule, we should check the contradicting literals, because we are trying to prove the statements through negation. And once you prove the goal statement, you can verify the result. You can construct a graph like structure to check whether the conclusion is logical conclusion is correct. For example, if you are having a statement like if a child finds cake or chocolate, then the child is happy. So this can be written as if P then Q, if A or B then Q. So this can be proved by contradiction. You can negate the goal statement, check whether the child is happy or not. You can negate the goal statement and generate logic statements for the statements a child finds cake, a child finds chocolate, a child finds cake or chocolate. So for all these statements you can generate propositional logic statements and then prove the conclusion. Similarly, for Wumbus world game, you can prove whether the statement is correct by contradiction. So if, for example, there is no base in a particular square and the agent is in square 1 comma 1, then you can conclude that there is no pit in nearby square. So this kind of statements can be proved by contradiction. You can apply inference rules, resolution inference rule for that. So this technique is widely used in theorem proving. If you want to prove a theorem by considering a set of statements, you can apply this and try to come up with the result. Either you prove the theorem or you disprove the theorem. And also you can maybe verify a single statement as true or false. Logically you can relate the statements, given statements, and then check whether the statement is satisfiable or not with respect to a particular conditions. And as I already told you, in the gaming technology also we can apply this resolution technique to solve the problem. So sometimes you need to derive conclusions by analyzing the facts which are represented in propositional logic statement. So you can apply this to solve the problem. Let us now discuss one example problem. We'll discuss a solution as well. So consider these statements. The humidity is high or the sky is cloudy. This is the first statement. The next statement is if the sky is cloudy, then it will rain. The third statement is if the humidity is high, then it is hot. The fourth statement is it is not hot. The goal statement is it will rain. Okay. So now let us use propositional logic. We will convert these statements into propositional logic statements, and then we will negate the goal statement. Thirdly, we will apply the resolution rule, inference rule, to prove the negated goal statement by relating the necessary classes. So first let us generate propositional logic statement for the first sentence. So there are two sentences connected in this particular sentence. So the humidity is high. Let us assume that P denotes humidity is high, and then let us denote Q denotes the sky is cloudy. So we can connect these two by using the OR operator. So P or Q denotes this particular statement. Next, let us convert the second statement. The second statement is If the sky is cloudy, then it will rain. So we can apply if P then Q form for this. Let us assume that Q denotes sky is cloudy, then R denotes it will rain. So if Q is true, then R is true. So we can apply implication to generate if Q then R. This is a logical formula for that statement 2. Then for the third statement, if the humidity is high, then it is hot. We will generate a propositional logic statement for this. Let us assume P denotes humidity is high and S denotes it is hot. So we can apply implication for this. If the condition humidity is high true, then the statement is true. It is hot, that is also true. So we can apply implication. We generate this if P then S formula. Then the fourth statement is it is not hot, right? So we have to take the negation of S. So already we have generated for the statement it is we have generated we have made a logical assumption. We have made an assumption for it is hot, the statement it is hot. So we use S to denote the statement it is hot. Now we can negate that because this statement, fourth statement, says it is not hot. So we have to take negation of S. Now from equation number 2, from step number 2, we can convert if Q then R into negation Q or R. So this is from Hahn class. So we can write this if Q then R as negation Q or R. Similarly, in step number 3, you can see we have the formula, logical formula, if P then S. This can be written as negation P or S. Now we have to negate the goal statement. The goal statement is what? It will rain, right? So we have used the notation R, right? So now we have to negate that R. So negation of R denotes it will not rain. Now we have to prove this goal statement by relating the necessary classes together. Now let us take P or Q and negation Q or R. So from these two, that is from step number 2, we generated negation Q or R. We are taking the statement, and P or Q already we generated in step number 1. We take these two classes together. From these two classes we derive P or R. Okay, so when we connect these classes by applying a resolution rule, we generate P or R. So the negative letter gets cancelled, we get P or R. Then we take the another class, that is negation P or S, which is generated from step number 3. So negation P or S is connected here. Now if you apply a resolution for these two classes, we cancel out this P and negation P, so we derive R or S. Now we will take negation S from step number 4. Now apply this inference rule, resolution inference rule. We cancel out S and negation S, we get R. Finally we take the negation R, there is a negated goal statement. Now if you see, this R and negation R get cancelled, we get null. So we proved that the given goal statement is true, right, by negation or by contradiction. So after applying this technique, resolution technique or proof by repetition technique on the goal statement, we finally derive null class. We resolve all the contradicting literals. So we have achieved the goal. So the goal says that it is not raining. The statement is true. The goal statement is true. It says that it is not raining. So that's all, guys. In the next lecture we will discuss resolution in predicate logic. We will solve the problem, we will discuss the steps, and then we will solve any one problem to understand how to apply resolution for solving a problems in predicate logic. Thank you guys.